All right, so just a review of trigonometry. It says the instructions say solve for the indicated side length or angle measure for the right triangle and round your answer to the nearest tenth. So what we have is just one generic triangle, and then we have math in each box. So we're going to reuse that triangle every time. Your options today are going to be Pythagorean Theorem or trigonometry. There's not any special right triangle tricks on here. So each box, it says little b is 4, little c is 5, find little a. Well, what is that talking about? Side lengths or angle measures? Side lengths. So if I have little a and little b, if I have little b and little c, it's going to be a squared plus b squared equals c squared. And I'm just trying to find out what a is by using Pythagorean Theorem. You're going to use Pythagorean Theorem a lot today. Do it in your calculator because it says round your answers to the nearest tenth. So how do you guys do this? Do you do it step by step by step, or do you do it all at once? Step by step by step. So in my calculator I can do it by hand. A squared, what is 4 squared? Plus 16, what is 5 squared? Okay, subtract 16 from both sides. And then take the square root. What is the square root of 9? 3. So little a equals 3. So 2 things I want to kind of give you guys today to speed your process up a little bit. When you're solving for a hypotenuse, or you're solving for C, you can do this. C equals the square root of a squared plus b squared. All right, that solves immediately for C, typing it all in at once. If you're solving for a leg, doesn't matter if it's A or B. Now, the first one doesn't matter. You can do a squared plus b squared or b squared plus a squared. The order does not matter. The second one is super important. It has to be c squared minus the other leg. So I can show you for this one, we're solving for a leg. So I can use the second formula. That looks like this. Menu, add a calculator. The square root of c squared minus b squared. Boom, 3, answer, done. Which is a different way to do it. It's really going to speed your process up. So having these on your paper somewhere might really speed up what's going on today. So there it is, number 1, a is little 3 or 3, and you're done, you move on. So let's use that same trick for number 2. It says you have A, you have C, and you're missing B, and you can reference this triangle in the upper right hand corner to remind you if you need to know what you're doing. So what are we doing to solve for B? A Pythagorean theorem or trigonometry? What do we do for the first one? Pythagorean theorem. So I have a squared plus b squared equals c squared. Because I'm solving for a leg, I can use this one right here. Just make sure that you do the square root of c squared minus a squared. So the square root of 13 squared minus 12 squared, we can type that in our calculator. The square root of 13 squared minus 12 squared. 5. Awesome. If you don't like doing it that way, you can go back to your way. I'm just trying to show you something that's a little faster. So b equals 5. If you do that the long way, you get 144 plus b squared equals 169. When you subtract 144 from both sides, b squared equals 25. Take the square root of 25, you get 5. They both do the same thing. I'm just trying to show you a faster way. Alright, so number 3 is kind of the same thing. Now we're looking for c. C is our hypotenuse. So we can go back and use this one. C is equal to the square root of a squared plus b squared. That's just using Pythagorean Theorem in a different form. So we do the square root of 12 squared plus the square root of 16 squared plus 12 squared. And I know for a fact you get 20. The square root, the square root of 16 squared plus 12 squared, 20. Oh, here we go. Who was not here Friday? Liars. All right. Oh, yes, everyone should have raised your hand because we had the day off. So why didn't you raise your hand? Who wasn't here Thursday? Anybody miss Thursday? All right, so here's where we have this thing. It says, I have to write this down or I'll never remember. So I have pencil, you have pencil. It says that A is 8, that B is 5.61, and C is 9.8. And we're trying to solve for A right there. We're trying to solve for the degree measure of angle A. So we went through 2 different pathways last week. We did trig, that solved for a side length, and we did trig, that solved for an angle measure. That's why I have these guys out right here, because they have all the formulas. So you can use a star chart, or you can use your notes that you have. So it says using inverse tangent. So it says tangent. And you have to remember what tangent means. Remember some old hipster caught another hipster tripping on apples? At least you remember, right? So that last part is tripping on apples. Tripping on apples. It says that tangent is equal to the ratio of opposite over adjacent. So I'm trying to solve for angle A, and I have to use tangent. It says tangent of A is equal to opposite over adjacent. What is opposite of A? What is opposite of A? What number? 8. What is adjacent to A? 5.61. Remember, opposite over adjacent. That is the tangent ratio. Now, if I'm solving for the angle measure, I can't use regular tangent. I have to use the inverse tangent. I have to move tangent over here, and it becomes inverse tangent. It's all set up. I just have to consult my math machine. Go to my calculator. Verify that it is in degree measure in the top right-hand corner. Degrees. If it is not in degrees, you did all that work for nothing. So you hit the trig button. And I want to use the inverse of tangent. That's right here. Inverse tangent. My ratio is 8 divided by 5.61. and it says 54.9599 rounding to the nearest tenth. Well, 54.95 rounds up to 55 is the answer. I know that angle A is 55 degrees. You cannot do that in your head. You cannot do that by hand. You can only do that in your calculator. 55 degrees. Thanks, right? So let me just take 1 second and go back and refresh your mind on trigonometry. So there's 4 answers. Okay, so on Friday we talked about this. We have 3 different trig ratios, sine, cosine, and tangent. And we said some old hipster caught another hipster tripping on apples. It says that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So I can use sine, cosine, and tangent here to try and figure out what all these ratios are. The first question on your test is going to say, what is the sine ratio for this triangle? So sine of A, or sine of 40, because I'm evaluating this angle, sine of 40 is equal to opposite over hypotenuse. Sine of 40 is equal to x over 13. That's what we did on Thursday. Sine of the angle is equal to opposite over hypotenuse. And I taught you guys how to solve that on Thursday. Right? Now, cosine of 40 is equal to adjacent over hypotenuse. Cosine of 40 is equal to adjacent over hypotenuse. That was caught another hipster. Cosine is adjacent over hypotenuse. And tangent, we just looked at tangent. Tangent is opposite over adjacent. That's the only trig function that does not use the hypotenuse. So the tangent of 40 is equal to adjacent over hypotenuse. Just setting up the ratios. So then we looked at like using sine, cosine, and tangent solves for a side length. Using inverse sine, inverse cosine, and inverse tangent solves for an angle measure. It was all about the discomfort of setting things up. So let's look at what's going on here. Is y'all all screwed up like that too? Oh, glorious. Let's do some sorting now. So 5 says find A. What does B mean? Oh, never mind, I got it. So 5 says, or number 6, B is 2, and C is 7.8. It says find A, little a, how would you do that? Trig or Pythagorean Theorem? So if you have two side lengths, that you go back to Pythagorean Theorem and solve for the third one. But if it says find A, the measure of angle A, is there any way to use Pythagorean Theorem to solve for that missing angle measure? No, so that's where you have to use trigonometry. It doesn't tell you which one to use. So we went through writing all three of them out and figuring out which one worked. Well, what do we have? If we have angle A, what is the 2? Is it opposite, adjacent, or hypotenuse? The 2 is adjacent. What is the 7.8? Hypotenuse. What is the trig function that is adjacent over hypotenuse? Cosine. So to solve for angle A, I have to do the cosine of A, and it's equal to the adjacent value over the hypotenuse value. Cosine of A is equal to 2 over 7.8. Adjacent over hypotenuse. Notice that's the big A, the angle A, not the side length A. So to solve for A, I have to move cosine over here. And it says A equals cosine negative 1 of 2 over 7.8. That's what I'm typing in my calculator for it to return an answer. And it should be an angle measure. Trig, cosine negative 1, inverse cosine of 2 divided by 7.8. And that's rounded to the nearest tenth, 75.1 degrees. All right, number 8, I'm going to erase my math off the triangle on the top. Number 8 says that C is 7.2 and that the measure of angle A is 33.7. It wants us to find B and it wants us to find A. So, can you use Pythagorean Theorem if you only have one side length? No. Now we have to use trig. So we can set up all three functions. The sine of 33.7, the cosine of 33.7, and the tangent of 33.7 is going to be equal to two equations that will work and two equations that will not work. So sine is opposite over hypotenuse. What is opposite of 33.7 degrees? A. What is the hypotenuse? Okay. Cosine is adjacent over hypotenuse. What is adjacent to 33.7? B. What is the hypotenuse? And tangent is equal to opposite over adjacent. What is opposite of 33.7? What is adjacent? Can I solve this? No. Bye, Felicia. You don't get to play math today. Those are the two things I need to solve for A and B. I told you guys a trick that decreased so much mathematics. Do you remember the trick? I wasn't here. Baker, tell me the trick. I feel left out. Here's the trick. If there is a number on the denominator, just trust me, this number travels to the front of the equation. and becomes 7.2 sine of 33.7 equals A. That nasty sentence can be typed into your calculator. You go to your calculator, 7.2 regular sine, because I'm solving for a side length of 33.7. Boom! 4. A is 4. Same thing for cosine. There is a number in the denominator. That number will travel to the front of the expression. Thank you. I'll get a few bless yous on the YouTube video too. 7.2 cosine of 33.7 equals B. Go back to my calculator, type in the same thing with cosine now. 7.2 cosine of 33.7. 6. What a monster, huh? Now, it's not the fact that, guys, I want you to get past this. It's not the fact that it's difficult. It's not difficult. It's just you don't know it yet. You're not comfortable with it yet. You can't do it out of your head yet. Most of you guys are not staring at a cheat sheet to tell you what is what. That's in your notes. I will give you a cheat sheet for the test. So practice that skill now and find your notes and find out where these expressions are so you can get comfortable finding a cheat sheet. I'm going to print those tomorrow and hand them to you. That way you have the cheat sheet, and they're also right here. Baker waiting formula chart at students for YouTube viewers, okay? So number 5 is Pythagorean Theorem. I think you're going to be fine with that. Let's look at number 10. Make sure you have those answers down because I'm about to erase them. You good? Number 10 says A is 2 and B is 2. Find the measure of angle A. I know what it is. Does anybody else know what it is? Though I didn't even have. No? Shame on you, huh? Were you here on Wednesday? Huh? The answer is 2. It's a 2-degree angle. You're funny. Yeah, but A is 2. You're right. Does anybody know how big the measure of angle A is? I'm gonna scribble this over here. I'm gonna block it with my head. Can you see it on my face? What? Oh, you see it over there? There it is, 45. I know it's 45 because it's an isosceles right triangle, and the only way for it to be an isosceles right triangle is if it's 2, 2, it's a 45, 45, 90 right triangle. But if you're not as intelligent as the guy in the front of the class, you can use trig to solve for it. So you have A, and you're trying to figure out what is that 2, or what are you missing? You're missing a hypotenuse. What is the only trig function that does not use the hypotenuse? Tangent, because he's looking at his notes. Tangent. So I have to use tangent. Tangent is opposite over adjacent. Right? Now if I'm trying to solve for A, if I'm trying to solve for an angle measure, I have to use the inverse of tangent. A is equal to tangent, -1, of 2 divided by 2. Trig, inverse tangent of 2 divided by 2. Boom! Oh my God, he's so smart. There it is. I'm just going to circle my answer and move it Way over here, because I'm lazy. I think I did half. Yeah? There is no way for me to give you homework on this stuff because you don't have calculators as smart as mine. Most of you don't. It's not a homework thing. If you have one, great. If you don't have one, use the time now. There is one problem that we have to negate. Number 14. Find the measure of A using the law of cosines. Huh? Using trig. Because the law of cosines is a squared equals b squared plus c squared minus 2bc cosine a. Huh? What? That was English? Do you care about law of cosines? No. Welcome to regular geometry. So if I was going to use trig to solve for the measure of angle A, I have little a is 7, little b is 7.8, and little c is 10.5. You can use any trigonometric function you want. Whoa, that says trigonometry, but using it as an application, trigonometric. It's fun to say, I'll let you try it. Trigonometric. Trigonometric. What? Trigonometric. But we're in the United States and we use the standard measurements, right? So you're using metric measurements, but trigonometric measurements. It's a good coffee today, guys. Pick one. Which one's your favorite one? Sine, cosine, or tangent? Tangent's your favorite one. So which one's your favorite angle, A or B? I know it's hard to decide, A or B. Flip a coin. A. So if you're going to use the tangent of A, you have to do opposite over adjacent. Type that in your calculator, you'll get the answer right there. What? Did you get that? Yeah? So y'all typed in tangent of 7 over 7.8 and got 41.81. I typed in the inverse sine of 7 over 10.5. We got the same answer. Because we're solving for the same angle. The angle does not discriminate in size based on the trigonometric function that you're using. So 41.8 is the measure of angle A. Oh man, this one looks tough. I'm already in it. Let's just go for it. Let's just keep going, right? I'm already stuck in. All right, I'm going to erase this real quick. We got A is 9, 45, 45, 90, find B and find C. Somebody impress me. If A is 9 of that isosceles right triangle. Right? Yeah, the measure of angle C is 90. How big is B? 9? Because it's isosceles, 9, 9. How do you get to the hypotenuse? Multiply by the square root of 2. Yay, math. 9, 9, and 9 square root of 2. Now, I think that you can't really do that on this paper because it says round your answer to the nearest tenth, doesn't it? But you can't just evaluate that. 12.7. A squared plus B squared equals C squared. A squared plus B squared equals C squared. Let me see here. Number 16, solve for the measure of angle B using inverse sine. So A is 16, little b is 6, and C is 17.1. And you have to use the inverse sine. So sine is, question mark, opposite over hypotenuse. So the sine of B is equal to opposite over hypotenuse. To solve for the angle measure, you move sine over. Type that bad boy in your calculator, and you get the measure of angle B.
Yeah, I did your
Oh, you know what? Because I was wrong, Jacques. I pulled the JJ. What? I was just making sure you guys are awake. My bad. A mistake is forever on the internet now. But your correction is forever on the internet as well. Cool? So yeah, slow down, make sure you do it right. Let's type it in and see what we get. Trig, solving for an angle, use the inverse, 6 divided by 17.1. Is that correct? Boom, 20.5. So B is 20.5. Now I have to use sine again to solve for angle A. So if sine is still opposite over hypotenuse, the sine of A is going to be equal to 16 over 17.1. And you get 69.3. I don't like that at all. 69.3. Why does that? Why do I not like that answer? Anybody? Why does that answer suck? Here's why. We got 20.5 and 69.3. 90 plus 20.5 plus 69.3. Oh, so close to 180, but it's not. Why does that happen? Anybody know why that happens? Because whoever created this problem rounded that number too far. Rounded that number too far. So usually we try to keep it to 4 decimal places. But the sheet just wants 1. Alright, I'll give you a little bit of time, give you the last 10 minutes to try a few by yourself. Just practice. Can't take it home. So take the last 10 minutes and see what you can do by yourself. This would be good practice for our test on Friday. When are we taking our test? Friday. Friday.